SAFE Software is pleased to present the 2009 FME International User Conference. This session is presented by Chris Jones and Khalid Siddiqui, both airport planners and senior consultants with Ricondo Associates. Chris specializes in land use and environmental planning, while Khalid specializes in the utilization of GIS for airport planning. They are both currently involved in the airport land use compatibility plans for 8 airports in San Diego County.
First, tell you a little bit about ourselves. Ricondo Associates is a full-service aviation consulting firm, and we are the lead technical consultant to the San Diego County Regional Airport Authority in the completion of an environmental documentation for airport land use compatibility plans for 5 public use airports in the county. And we're currently working with the authority and developing ALUCPs for San Diego International Airport and 2 military facilities in the county. We want to start our presentation by first telling you a little bit about airport land use compatibility plans. Then we'll discuss the Mozzie Ranch case, which had a pretty distinct impact on ALUCPs and the process required to create them, and the development displacement analysis for which we used FME in support of our ALUCPs. First, ALUCPs deal with the determination of compatible land use in communities surrounding airports. Some of the primary issues are encroachment by surrounding communities, which leads to development that's incompatible with airport operations. And this increases danger to the public and to buildings within the areas around the airports. Also puts the risk of the safety of aircraft occupants up there because, if you're going to crash into a building, it's obviously going to cause you a lot more pain than crashing into an open field. And then there's the economic constraints that need to be taken into consideration, because when you constrain the ability of an airport to operate to its full capacity, it's going to have an impact on the local economy. So anticipating these issues, the California State Legislature created airport land use commissions back in the 60s. And the ALUCs are required to complete airport land use compatibility plans for all the public use and military airports in the state of California. So our policies in the airport land use compatibility plans are based around 4 factors: safety, noise, airspace, and overflight notification. And for purposes of land use planning, our primary focus is on noise and safety zones. These are used, the compatibility criteria that are developed based upon the noise and safety impacts associated with the airport are used to develop or used to review proposed development in areas around the airport for compatibility. So in general, we put up about 5 to 6 safety zones around each airport, and each zone is a geometrical area that represents a relatively uniform level of risk that's distinct from the other geometrically determined zones. And then we have our noise contours, which basically represent uniform areas of average noise level. 65 dB CNEL is our threshold for compatibility in general in the state of California. So these are the 6 safety zones that were developed for McClellan-Palomar Airport, which is the airport we're going to be discussing today. This airport's located about 50 kilometers north of downtown San Diego. It's a general use reliever airport for San Diego International. And as you can see, the red areas that are closer to the runways are the areas with the highest risk for accident. Sorry, I'm supposed to be pointing with my fingers. These areas represent the departure or the arrival zones and departure zones, and these are the areas where you're going to have a higher risk for accident potential. And as the areas lighten up, your risk tends to lessen as well.
Safety zone 1s are basically RPZs. Right?
Yeah. The safety zones generally reflect the same area as a runway protection zone, and this geometry is determined by FAA. These are noise contours that were developed for McClellan-Palomar Airport, and as you can see, these sort of represent the pattern of operations at the airport. We have west flow operations most of the time, which means that the wind blows from the west towards the airport, and aircraft, they depart into the wind. They need the lift.
Kind of interesting. It's a little sharper. It's like a tail here because all the arrivals are coming in very tight, and then when they take off on this side, they start to go north. And
right. As they depart, they fan out. So the Mozzie Ranch case, basically, I'll give you a brief rundown of the facts of the case. The Solano County Airport Land Use Commission prepared a land use compatibility plan for Travis Air Force Base. The ALUCP affected an area of about 1,500 square kilometers, and Mozzie Ranch Company owned a piece of property that was about 400 hectares in size within this 1,500 square kilometer area. And the LUCP limited the amount of residential development that would be allowed in this area, and so Mozzie Ranch sued, claiming that the LUCP needed to conduct an environmental impact report in order to assess all of the impacts associated with its implementation. And the court agreed. See, in the state of California, local jurisdictions are required to identify adequate areas for future housing and other land use in their planning. And so the potential for future development can be affected by implementation of ALUCPs, because ALUCPs, they limit the intensity, which is the number of people allowed per acre, and also density, which is like, say, the number of dwelling units that are allowed. So a county might plan for huge housing development in this area. ALUCP is implemented and says, no, you can't put all that housing there, so they have to move it to another part of the county, and that can lead to displacement of population and housing, but also other effects like an increase in traffic congestion and air quality impacts associated with, traffic in an area that wasn't planned. And so we had to prepare development displacement analyses for each of our ALUCPs, and our goal was to identify the total area of any land use that would be displaced as a result of the implementation of the ALUCP. And land uses, we brought it down to basically the bottom level that we possibly could, which was to identify each permitted use that was allowed under the zoning designation in the affected jurisdiction. And we focused on a parcel-by-parcel basis. So what we wanted to determine was which one of these permitted uses would be allowed and would not be allowed for each parcel. And we grouped it into 4 general categories. We had residential uses, where we basically looked at the maximum number of dwelling units that would be allowed per acre. Agricultural open space uses, where we accounted for basically the entire acreage of any given parcel. Commercial, industrial, and public uses, where we calculated the maximum buildable square area that might potentially be displaced. And this slide's kind of redundant, but here's a map of San Diego County, and this shows all the airports that we've been working on. And so we're going to discuss the development displacement analysis for McClellan-Palomar Airport, which is right there. Sorry, move the mouse. Right there. Downtown San Diego is right over here. The first step in the preparation for our analysis was, of course, to collect the appropriate data. So we acquired a number of shape files from SANDAG, which is the regional planning agency, and SANGIS, which is the regional GIS clearinghouse. We also acquired existing building square footage for every parcel in San Diego County from the county tax assessor's office. And we also had to identify our impact area boundary and then create crosswalks. This is our impact area boundary, and basically it's just a combination of our 6 safety zones along with our noise contours. The criteria within each of these areas is different. It's distinct from locations in the other noise contours, the other safety zones. And our crosswalks, which were basically Excel workbooks, identified all of the permitted uses under each zoning designation, and then we equated them to uses that were listed in compatible land or in safety compatibility and noise criteria matrices included in the ALUCPs. And the ALUCP criteria basically identified the compatibility of land uses based upon the locations within each safety zone and each noise contour, and basically told us whether land use was compatible, conditionally compatible, or incompatible. Conditionally compatible land uses meant that you could be allowed to build something in that area, but it would be limited to, say, a floor area ratio determined by the ALUCP.
So this is step 2. This is where the FME analysis starts to take place. The first workspace performed multiple tasks simultaneously. I guess that was the complexity of the workspace, was there's multiple feeds going in the same direction. There was elimination, attribution, and assigning of values in the first workspace. The elimination, we reviewed the parcels within impact area boundary for inclusion in the study sample database. Basically, any parcel that was intersected by our studies, our impact area boundary, we took into account. But we needed another subset analysis taking into account all the parcels that were 10% or greater intersected, so that we could reduce our sample size.
It reached a point where we would have enormous parcels that were only maybe 1% included in the impact area boundary, and it just didn't make any sense to, evaluate those for displacement loss when so little of the area was actually included within the area of our boundary.
We also removed federally owned parcels as well.
Yeah, this is a California state legislation, so it doesn't apply to federally owned lands.
So this is what our first workspace looked like. So this is where we're eliminating the parcels based on the safety zones and the noise contours.
So if they weren't intersected by our safety zones or noise contours, they were kicked out.
Right. This is where the analysis starts to take into account the 10% inside criteria, I believe. And this is where we also removed the federally owned parcels.
So in the end, this is our study area, and in gold, these are the basically outlines of all the parcels that were included in the initial part of our analysis.
So the elimination of parcels, parcels determined not to be developable. So developable happens so many times in the slide, it kind of gets a little tongue twisting.
Right.
Undevelopable parcels, which are federally owned parcels. Parcels with entitlements, so if an owner had a building permit issued, then we eliminated those ones as well. Parcels under development and parcels already fully developed.
It's important to note fully developed because we did account for infill potential for parcels. So if a parcel had a building on only 50% of the area, then we actually did go ahead and calculate for the potential of full development of the parcel. So these are actually all the parcels that were kicked out at this point, which is, as you can see, the vast majority of our parcels were eliminated from the analysis.
So attribution, basically we had 14 to 15 different layers and data sets that were overlaid on top of our parcels, and all the attributes from those parcels were assigned to, from those layers to our parcels basically. So zoning designations, design standards, development, infill potential, noise contour values, safety zone values, existing building square footage, and other attributes. Again, to note that they're all in different formats. Some were in shape files.
Design standards, for example, those were Excel workbooks that we put together that basically brought all the design standards from the zoning ordinance of the affected jurisdictions and compiled them into tables. The existing building square footage was, I believe, a comma-separated value text file.
Yeah.
It was a really big file, every parcel in the county.
So this is where the attribution took place. Basically, basically if a parcel fell within 2 noise contours or 2 safety zones, basically we would take the more restricted value of that safety zone or noise contour into account for our analysis.
That's basically what we wanted to do in order to ensure the most conservative analysis possible.
FME allowed us to eliminate all parcels to be excluded from the analysis, assign importance to noise contour levels as well as safety zones. And one of the interesting things was we wanted to, from the get-go, understand where all our source data is coming from and all the attributes are coming from. So we were able to prefix the fields with, I guess, a source name of some sort to let us know that, okay, this came from this field or this data set, and this came from another data set. FME also allowed us to go back and revise tolerance levels. So we came into an issue where the devable layer and the redev infill layer, the geometry did not match our parcels geometry, and it was based on the intersection. We were taking into account many more parcels that we did not need. So only like 5% of the parcel next to it was getting overlap because some guy sloppily drew those lines in. So we were like, well, why are we having so many parcels being included? So instead of doing just a strict intersection, we changed it to a 95% inside. So if that parcel fell within 95%, if the 95% of the parcel fell within the 2 layers, then it would get assigned that value of that attribute. So it allowed us to go back and refine our standards or our tolerance levels.
And these 2 files were absolutely key to our analysis. Devable basically identifies all the parcels that are developable within the county, and redev-inf identifies all of those parcels that are either redevelopable or have infill potential. So without these 2 layer files, we have no analysis.
Right. It also allowed us to add new attributes to the study, sample parcel database like community planning areas, as you'll see in the next slide.
Well, actually, we didn't have community planning areas for this analysis. That was
that was another one. Okay.
Another one, yeah. The community planning areas were important in San Diego County and in the city. They actually have bring their planning down to even smaller areas than the jurisdiction as a whole, and they'll have different design standards associated with those areas, so we had to account for those as well.
So the second FME workspace assigned the study area parcels with the overlay zone. So through our process, Chris realized that we needed to add more data and attributes to our analysis to finish.
City of Carlsbad, in which McClellan-Palomar Airport is located, has a number of overlay zones that have more restrictive design standards than the base zones underneath. So, for example, if you have the Coastal Resource Protection Zone, which overlays a number of different base zones, you're going to find that your ability to build a taller building or a certain number of floors is going to be restricted due to the overlay zone, and that directly affected our ability to calculate a maximum buildable square footage for each parcel. Yep.
So this is our second workspace. Basically, it's a simple workspace where you have multiple overlay zones that are just going through and creating a new geodatabase. Third workspace merged the first and second results, I believe, and then added crosswalks into it, which Chris will talk about a little bit more, and then we finally got our results. So this is where the first two workspaces results are coming in. Next. This is where the crosswalks, which are spreadsheets and workbooks in Excel, are coming in and kind of getting prepared, I believe. The two data sets here are coming together now, and then this is where the crosswalks are coming into play, and I'll let Chris kind of explain that a little bit better.
Well, the crosswalks, basically, as I explained before, we took each zoning designation that was, basically the zoning designation within our impact area boundary. And each zoning designation has any given number of permittable uses the city would allow. So for example, if you have like a light industrial zone, you're going to be allowed maybe 45, 50 different uses. So we wanted to account for the potential displacement of each individual use. So we had to equate each one of those permitted uses to comparable permitted use in the safety zone and noise compatibility criteria in the LUCP, and that's how we determined whether it was compatible, conditionally compatible, or incompatible.
Actually, go back. I want to touch on one thing. I kind of touch on it at the end, but
back?
Where's my mouse? No, this is. Go
okay.
Forward one.
Oh no, you're right there. That's
right here. This was really key for Chris because all the uses from the crosswalks, the zoning categories, and from our geodatabase, the geometry, which had all the zoning categories, wherever they did not match, the unmatched were getting dumped out to here, and I thank Dave for this. Dave. So then we knew that these zoning categories were not matched. So then Chris was able to go back and refigure out what zoning categories mean what and why, and then if they were important, we'd have to go back and rework some things to push it through again. So hopefully in the end, there would be nothing getting dumped out to the unmatched category. So that's one of the benefits of FME, is that you can start to see all these things through the data model, opposed to, if you're doing it in GIS, you kind of have to just do this one by one, very linearly, whereas you can see this kind of simultaneously at the same time.
To give you some indication of how big these crosswalks are, the crosswalk we prepared for the city of San Diego was about 985 pages long. These are really big files.
And you can imagine how many uses, and you probably explain this better, how many uses were displaced. Like there's like hundreds per each category,
Well, sometimes you have a parcel that might have 100 different allowable uses, and only 5 of those uses might be potentially displaced. So all that means is that whoever owns that land can't develop those 5 things that would otherwise be allowed under the zoning.
Right. So at the end, our results, we had geodatabases for myself to create these pretty exhibits, and access databases and Excel files for Chris to further calculate the final displacement loss.
So I just got the 5-minute mark here, so let's wrap this up. These were our parcels that eventually showed that they had potential for displacement loss. And as Khaled had explained, we basically used Excel files to calculate the potential development displacement loss for all the permitted land uses for each one of these parcels. So that required calculation. For example, if we had parcels that allowed residential use, an agricultural use, a commercial industrial use, or a public use, we had to calculate for all of these different uses. And so these are the parcels that we ended up showing displacement loss. Not very many, fortunately.
Right.
So, and this is a final summary showing the disposition of all of our parcels. So here are the benefits of using FME.
Yeah, the benefits of using FME, very easy to make adjustments to the analysis to account for unforeseen problems like the redev and the development issue that we had, and the tolerance levels. FME allows for a very simplified multi-format analysis in one platform. I love the fact that you can take all these different formats and put them in and spit it out in whatever format you need to do the analysis in at the end. Saves significant amount of time and energy in a complex analytical environment. Doing it in GIS singularly would just be too complex. And the workspaces or parts of the workspaces are easily retrofitted to use in other projects. So,
thank you.
Thank you very much. And I also like to thank Safe and Dave for very much
thanks to
helping
Dave.
us
It's a big
with
help.
this project.